Alright, this video is for implicit differentiation. It's pretty much different. Implicit differentiation is pretty much you do it when what is not easy for you to get y by itself. You know, usually when you mix in x and y's in the function together, it's kind of hard to take out just one y because usually different powers of y. So they came up with implicit differentiation, which it's not too bad. So look at the base. The basic example is always just x times y is equal to, oh, let's say 1, right? Um, so it's differentiated. The first we can do it the basic way, which obviously we can divide both sides by x. So you get y is equal to 1 over x. And the derivative of that will just be, because it's the same thing as saying x is negative 1, it's negative x negative 2. Correct? But sometimes, like I said, sometimes it's not this easy, so we can do it implicitly. So the way I like to think about it, I know how the book says chain rule, and kind of chain rule kind of just confuses you. Chain rule, they pretty much just mean chain rule because they say x is what's inside y. But you don't really have to treat this the chain rule way. You can just treat it like the product rule. So it's x and y. So let's say x is u, and then y is v, right? So the product rule says the derivative of this has to be u prime v plus u v prime. So let's do that. So what is the derivative of x in respect to x? That's the key thing. You got to do everything with respect to x. So x, derivative of x with respect to x is just 1, and then v just stays the same, and then u is just x. And what is the derivative of y? Well, y is just dy over dx, which we like to write it as y prime. So we write that as y prime. So the derivative of this is y plus xy prime is equal to 0. Alright, you got to get y prime by itself now. Take the y to this side, so you're left with x y prime is equal to negative y. Divide both sides by that, by x. Y prime is equal to negative y over x. And if we do it up here, if we use what we did over here, y is equal to 1 over x, put in 1 over x over here, and it gives you the same thing. So this is pretty much the easiest way to do it. So now that you have the derivative, you can do whatever they want you to do, like find the slope of the equation of the tangent line. This is not your slope, so you just plug in your 2 points into it, and it'll be it. So let's do a couple more practice problems, because obviously just one is never enough. So the first one is x cubed y cubed minus y is equal to x. So we have to differentiate both sides, and let's start doing that. Alright, so again, like I said, treat it as product rule. So this is u, this is v. So what is the derivative of x cubed? Will be 3x squared, and then v stays the same, v cubed plus, x cubed stays the same, and the derivative of 3y of y cubed will be 3y squared y prime. The key thing is every time you take a derivative of y, you have to write the y prime after it. So you treat it the same, and then you just have to write y prime after it. So derivative of 3y is 3y squared, but since we're doing it with respect to x, is dy dx. So we have to write y prime after it. So I want to say maybe that's the hardest part of it all. You always have to write y prime after every time you differentiate the y. And then minus y, derivative of y is just 1, so it will be 1 y prime. And derivative of x is just 1. So now we want to group. So now whatever doesn't have a y prime, we have to take to the other side, and then we have to group all the y primes together. So let's take 3x squared y cubed to the other side, so we'll be left with x cubed times 3y squared y prime minus y prime is equal to 1 minus 3x squared y cubed. Now since both of these have y prime, we can always factor out a y prime. So we factor out a y prime, we are left with x cubed, let's just write this, 3x cubed y squared minus 1. So remember that's a 1 because there's an imaginary 1 there. Is equal to the same thing that's on the right side. Now how you get rid of this, since both of these are multiplying, obviously you have to divide by them. So y prime is equal to 1 minus 3x squared y cubed divided by 3x cubed y squared minus 1. So now this is your derivative of the function. And they're asking you to find the slope of the tangent line at whatever, like at 0, 1 or 1, 2. You plug in 1 for your x and 2 for your y, and then it will give you your slope that will give you the slope of the tangent line, and then you just use the regular equation. Okay, next one, we'll be dealing with cosines with sines and cosines. So sine x plus 2 cosine y is equal to 1. Alright, so just don't be scared because it has sine and you haven't seen it before. It's okay. It's all good. It's the same thing. So what is the derivative? What is the derivative of sine? Cosine x plus, now with y. So again, this is a little bit more like chain rule again. Just cosine of 2y, so the 2 always stays here. So again, you always have to do derivative of the outside with the same inside times derivative of the inside. So derivative of the outside will be what? Negative sine. So negative sine 2y. The 2y, the inside always stays the same, times derivative of the inside. Now what is derivative of 2y? Will be 2y prime, and derivative of 1 is just 0. So let's look at it. Let's look at this again. We hear more space. So cosine 2y. Let's just say this is u. So cosine of u. Sorry. So this is a little bit more. It'll be easier just for C. So what is the derivative of u? Since we're doing 2y, so u prime will give us 2, and derivative of y will be y prime. Okay. So now cosine of u, so it'll be the derivative of the outside function, which is the cosine, which is negative sine with the same inside, times derivative of the inside. Alright, so now we just plug everything in. Be negative 2y prime times sine 2y, and that's exactly what we got here. So now let's make everything look pretty. Plus negative 4y prime sine 2y is equal to 0. Take cosine to the other side, you're left with negative 4y prime sine 2y is equal to negative cosine of x. Factor out, oh, you don't really have to factor out because the y prime, there's only one y prime, so you divide everything by negative 4 sine 2y. So it becomes y prime is equal to, the negative will cancel, so you'll be left with cosine of x divided by 4 sine of 2y. And again, it was just, again, if they ask you for a tangent of the line, you just plug in your points and you go from there. Yeah. Alright, so sine x is equal to x times 1 plus 10y. So again, what's the derivative of sine? Be cosine x is equal to, hold on. Let's distribute the x here. I don't like to work on with, I like to always distribute, makes everything a lot easier. So it'll be sine x is equal to x plus x tan of y. Alright, so now we can differentiate everything with respect to x. So derivative of sine will be cosine of x is equal to derivative of x is just 1 plus, okay, now this is the product rule. So let's do it over here. So it'll be x tan y. So again, this is our u, this is our v. So what's the derivative of x with respect to x is just 1. So it'll be 1 tan y plus the x takes its tan. Derivative of tangent is secant. So secant squared of x. And derivative of the inside of y is always y prime. Okay. Alright, so let's plug this in here. So it'll be 1 plus 10y plus x y prime secant squared of y. So take everything else that doesn't have a y prime to the other side, which would be just this. So it'll be cosine of x minus 1 minus 10y is equal to x secant squared y prime. So we divide by x secant squared on both sides. So y prime is equal to cosine x minus 1 minus 10y divided by x secant squared of y. And again, that's all pretty much you need to know. It's not too bad. Alright, the next one. The next one will be a little bit tricky, but it's pretty much the same thing. Just don't freak out whenever you have functions inside functions involving x and y. So it's the same thing. This is more the chain rule. So sine, let's call this u. Okay, all the inside is u. So our function will be y is equal to sine u. Now how you take a derivative of sine u, right? You always do derivative of the outside with the same inside times derivative of the inside. So derivative of the outside function, start over here. Derivative of the outside function is sine, so derivative of sine is cosine. So cosine with the same inside times u prime, right? And since u is equal to xy, then u prime, again this is more like the product rule, x, derivative of x is just 1 y plus x y prime. So this is your u prime. So the derivative of y will be y prime. Y prime is equal to u prime times cosine u. So u prime was y plus xy prime. So y plus xy prime divided by, times sine of x, y. Alright. Since we have y prime here, but y prime is multiplied by sine y, so we have to distribute everything in sine y. So it becomes y prime is equal to y sine xy. No, not sine. Sorry, cosine. Sorry, guys. Cosine. Yeah, I just didn't write it right. Because remember, derivative of the outside function is cosine, so this should be cosine. Cosine xy. So now you distribute cosine xy into each function. So y prime is equal to y cosine xy plus x y prime cosine of xy. So now we got to group our y primes together and then divide. So y primes together will be y prime minus x y prime cosine xy is equal to y cosine xy. Now we can factor out a y prime. Let's do it over here. Alright. So let's factor out a y prime from both sides, and we'll give us y prime. Take it to the outside. You have a 1 minus x cosine xy is equal to y cosine xy. Now we have to divide by 1 minus x cosine xy. So y prime is equal to y cosine xy divided by 1 minus x cosine xy. So it wasn't too bad. It's just a lot of always algebra. You always can use algebra. Calculus is very, very heavy set on algebra. So again, let's go through that one again. So we just made x, y, u, right? So we take derivative of sine u, which is cosine u times u prime. Since u is x, y, u prime is y plus x, y prime. You should be used to this example. This is the first example we did. It's the first example you always do. Is equal to this. So now we just plug it back in. So it's u prime. So it'll be y plus xy prime times cosine xy. So then you have to distribute cosine xy into both things. So y prime is equal to y cosine xy plus xy prime cosine xy. Now you have to group your y primes together. That is one of the most important step. You always have to group your y primes together in order for you to get y prime by itself. So group y prime together, so you got to take the y prime to the other side. So you give you y prime minus, since it takes it to the other side, will be minus xy prime cosine xy is equal to cosine to y cosine xy. So now we factor out a y prime. Since both of these have y prime, we can factor it out. So y prime times 1 minus x cosine xy is equal to y cosine xy. How you get y prime by itself? Well, you divide by 1 minus x cosine xy. And final answer will be this. Now since you have this, now this is your derivative. Now you can do anything else you want to do in calculus. Find the tangent line, find the max or min, anything else with it.